Hey again, guys. I'm going to go ahead and do parts C and D now. The good thing about part C actually is if you were ready for yesterday's class and you were expecting a graded warm-up, this would have been the question. Find the total distance traveled by an object over a particular time interval, and the curve is defined parametrically. So that's essentially our arc length formula for parametrics. And the good thing is they already gave us the dx dt and the dy dt. So for arc length, we're going to integrate from 0 to 1 because that's what they told us to do, and we're basically going to add up all those segments. So if you kind of follow the speed concept and you sort of mix it up with arc length, well, this is arc length. So hopefully you'll keep that straight. So dx dt squared, again, same thing as before, plus dy dt squared, and dt, and we're going to have to integrate that. So this one, I think most people were able to set it up. I think what happened was putting in the calculator tended to be a bit of a tricky situation with all of the parentheses and having to square the trig function itself. So I'm literally going to type it in as it looks so that I try to make as few mistakes as possible. So let's see if we can get it on the first try. All right, so clear that out. So I'm going to do Math 9, and it's going to be the square root of, all right, so the first thing I need is cosine of t cubed squared. So I'm going to put a parenthesis around cosine. So cosine of t cubed, or x cubed, doesn't really matter. The first parenthesis closes, let's see if I can show this. The first parenthesis closes my x cubed. My second parenthesis closes my cosine, and that's what I want to square. And I'm not going to do the last parenthesis yet because I'm not done with my square root. Okay? So plus another parenthesis, 3 sine x squared, close the parenthesis for the x squared, close the parenthesis for the 3 sine of x squared, which I also want to square. And then now I can close the parenthesis on my square root. I have one more parenthesis, which is my entire integral, but before I do that, I have to do comma x, comma 0, comma 1, close the last parenthesis, and before I hit enter, I can double check. How many left parentheses do I have? 1, 2, 3, 4, 5, 6 lefts. How many right ones do I have? 1, 2, 3, 4, 5, 6. Okay, so I at least have the right number of them. The question is, did I put them in the right place? And let's see. Enter. 1.4583 or whatever it is, which I know is the right answer. I remember. And there you go. That's it. Okay, so there's your arc length. So that actually wasn't a big deal. And most people didn't have trouble with the setup. I'm telling you, I think at least 3/4 of the students between periods 3 and period 7 messed up a parenthesis somewhere or squaring something wrong or whatever. Okay, so that's that one. No big deal. That was, if you were prepared for yesterday's class, you would have gotten that no problem. All right, now for the last one. And this is the one that I think gave people the most trouble conceptually. Oops, cancel that. And the question was asking to find the position of the object at time equals 3. The position of the object, well, they're giving us the velocity components, and I want to go backwards. If you remember when we did our vector breakdown, right? When we did our vector breakdown, we realized we were given the velocity vector, but they're asking me something about the position vector. Well, we've done stuff like that before. We've gone from velocity back to position. And some of you in class were like, oh yeah, just take the antiderivative, no problem. Okay, good luck with that. Good luck taking this antiderivative. Good luck taking this antiderivative. I can't take those antiderivatives, so we have to use integration where we'll be able to use our calculators. But how do you do that when they're asking you for a specific point? They're asking you, I hate that. They're asking you for the position of the object at time equals 3. Well, this is the part where some of you missed the initial condition. They gave us at time equals 2, the object is at 4, 5. So I'm going to write that down. So at time equals 2, the object is at 4, 5. Okay, that's important. And they want to know, we want to know at t equals 3. Okay, let me pull back the other screen. So that's what I wrote. At time equals 2, the object is at 4, 5, and we want to know where the object is at time equals 3. Well, when I go to set up this integral, I'm going to use the 2 and the 3. And this is how I show it. I think I got to show this in period 7. I don't think we had time in period 3. So this is what I basically said. I said, what if What if I just generalize this like that? The integral from 2 to 3 of f prime of x. What would that be? Well, the antiderivative of f prime would be f, but I'd have to evaluate it at 3 minus 2. Well, I know what the values are at 2. I want the values at 3, and this I can get from the calculator. So you just have to work a little bit backwards. Okay, I can find this in the calculator, and then I can add in whatever my value was from 2 into that integral after I've done it, and that should leave me with whatever f of 3 is. So let's watch that happen. So I'm going to integrate from 2 to 3. We got to do one component at a time. I'll do my x's first. For cosine t cubed dt, well, that should equal x of 3 minus x of 2. And I want the position at 3, so I'm going to add the position of 2 at 2 to both sides. And this is the equation you can use to actually solve my x component. Okay, and x of 2, of course, is 4. So 4 plus, let's get this in the calculator. Let's see, let's clear that out. Math 9, and this time I'm going to do cosine of t cubed. So just cosine of t cubed, x cubed. That takes care of that. There's nothing fancy here. Comma x, comma 2, comma 3. So 4 plus, wait for it, negative 0.046498091 equals x of 3. And again, I'm using more decimals than I need, but I want to make sure that my last final answer is not rounded too much, so I'm going to add 4 to this. So 3.95, 3 or 4 would be fine. I'm going to go with 4 just out of force of habit. And there's my position at 3. 3.954. Okay, got to do it one more time, but this time I'm going to do it for my y coordinate. So I'm going to do, is it okay if I just write it like this? And my y dy dt is 3 sine of t squared. And that's going to equal my y of 3. Okay, basically I just copied the same exact thing I did down here, except for y. Y of 2, let's see, that is 5. Y of 2 is 5, right? This is x and y. So 5 plus, all right, calculator action. Let's see, let's bring that back. This is going to be 3 sine x squared. Let's see, 3 sine x squared comma x comma 2 comma 3. And that's going to be negative 0.0936418873, which is y of 3. Basically just add 5 to that, and I get 4.906, and that's probably good enough for y of 3. So there's my y value, there's my x value, down here, there's my x value. And how did they word the question? Do I have to put it in a particular form? Let me just double check. Please find the position of the object. Okay, so I can just literally write the position of the object is 3.954, comma 4.906. Have a nice day. Okay. All right. I also have on the other slide, I believe, I have all the answers. Okay. And you can see the same answers obviously we got, but if you want to just have this so you can, in case I wrote it too messy and you couldn't read it, and it also has some of the setups that you can look at, and hopefully that helps. So this is pretty much the AP style that you need to be able to do when it comes to parametrics. Now, some of the multiple choice may also have, these components to them, but if you can do them on the free response, you'll definitely be able to do them on the multiple choice. Okay, let me know if you have any questions. The 3 AP style free response are on the calendar, so you know which one it is. If you need any help finding them, please let me know. And have a great weekend. I will talk to you guys later. Peace.